In this video, let's see the second category of unbalanced three-phase system, that is unbalanced three-phase four-wire star-connected load. Figure shows an unbalanced star load connected to a balanced three-phase four-wire supply. Here, star point N of the load is get connected to star point O of the source. The star point of the supply O, that is generator, and the load N are at same potential. These 2 points are at same potential. It means that voltage across each load impedance is equal to the phase voltage of the supply, that is generator. That means the voltage across three load impedances are equalized even though loads are unequal. In the case of star connected system, phase current is equal to line current. These line current or phase currents are different in the case of unbalanced three-phase four-wire system. As these currents are unbalanced, there should be some neutral current. So when we are applying KCL at this node, we can see some neutral current is there. That neutral current is vector sum of these line currents. We can calculate I phase similar way as we discussed in delta connected unbalanced system. As we know, for star connected load, line voltage and phase voltages are related like this. VL is equal to root 3 V phase and IL is equal to I phase. Let's take VRN as a reference. Let VRN is equal to V phase angle 0, VYN is V phase angle minus 120 degree and VBNB V phase angle minus 240 degree. Now, when we are considering these three-phase four-wire unbalanced load, this line current IR is equal to this voltage across this impedance divided by its impedance value, that is VRN divided by ZR. Similarly, IY is equal to VYN divided by ZY. And finally, IB is equal to VBN divided by ZB. Once we got phase current in the case of star connected load, that is nothing but line current itself. Once we got line current, we can find out neutral current by applying KCL over here. That is, IN is equal to IR plus IY plus IB, which is nothing but vector sum of three line current. So, vector sum of three line current gives neutral current. In order to see how to solve this type of circuit, let's consider an example. Here the question is, a three-phase 400 volt four-wire system has star-connected load with ZR is equal to 10 plus J0 ohm, ZY is equal to 15 plus J10 ohm, and ZC is equal to 0 plus J5 ohm. Here we need to find line current and neutral current. Here this is the circuit. Here ZR is given as 10 plus J0 ohm, ZY is 15 plus J10 ohm, and ZB is J5 ohm. Here, first of all, we need to find out these line currents by means of these expressions, and we need to find out this neutral current by means of this expression. So here the given parameters are line voltage is given, that is 400 volt, V phase is equal to VL by root 3. We can obtain V phase as 230.94 volt. ZR is 10 plus J0. When we are converting that into polar form, it is equal to 10 angle 0 degree, that much ohm. ZY is equal to 15 plus J10. When we are converting that into polar form, it is coming as 18.03 angle 33.69 ohm. And ZB is equal to 5 angle 90 degree, that much ohm. Now let's take VRN as reference. VRN is V phase angle 0 degree. So 230.94 angle 0 degree, VYN is 230.94 angle minus 120 degree, and VBN is equal to 230.94 angle minus 240 degree, that much volt. Now we can calculate the phase currents. IR is equal to VRN divided by ZR, which is equal to 230.94 angle 0 degree divided by 10 angle 0 degrees. After solving, we can obtain the result as 23.09 angle 0 degree ampere. And similarly, IY is equal to VYN divided by ZY. Substituting these values, we can obtain IY as 12.8 angle minus 153.69 degree, that much ampere. And finally, IB is equal to VBN divided by ZB. Substituting VBN and ZB in this equation, we can obtain IB as 46.19 angle 30 degree, that much ampere. As we know, in the case of star connected load, line current is equal to phase current. So this phase current is exactly equal to line current. So line current in R phase is this one, line current in Y phase is this one, and line current in B phase is this one. Now, in order to find out neutral current, we need to find out the vector sum of this one. We need to add these quantities in order to obtain neutral current like this. After adding IR, IY and IB, we can obtain neutral current as 54.47 angle 18.65 degree, that much ampere. So problem associated with unbalanced 3-phase 4-wire star connected load is very simple. Here, in order to solve this problem, first of all, you need to convert these impedances into polar form for simplicity. Then we need to find out this current, that is phase current, by means of this expression. Once you got this phase current, that is equal to IL, that is line current, then sum of this line current gives neutral current. That's all. Once we got these lines current, we can easily find out real power or reactive power.